is round. There's proof abound, don't fool around. The data's sound, the earth is round. Like an apple or a melon, being sailed by brave Magellan. Yet you ask, is this all true? What the hell, what's wrong with you? Like a snowball or a beat, it spins through space, it's really sweet. Your lack of science is quite rife. Goodness gracious, get alive. Round, 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 the earth is round. Smart people found that the earth is round. There's proof abound, don't fool around. The data's sound, the earth is round. Like an apple or a melon, being sailed by brave Magellan. Yet you ask, is this all true? What the hell, what's wrong with you? Like a snowball or a beat, it spins through space, it's really sweet. Your lack of science is quite rife. Goodness gracious, get alive. Round, 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 the earth is round. Smart people found that the earth is round. There's proof abound, don't fool around. The data's sound, the earth is round. Like an apple or a melon, being sailed by brave Magellan. Yet you ask, is this all true? What the hell, what's wrong with you? Like a snowball or a beat, it spins through space, it's really sweet. Your lack of science is quite rife. Goodness gracious, get alive. Round, 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 the earth is round. Smart people found that the earth is round. There's proof abound, don't fool around. The data's sound, the earth is round. Like an apple or a melon, being sailed by brave Magellan. Yet you ask, is this all true? What the hell, what's wrong with you? Like a snowball or a beat, it spins through space, it's really sweet. Your lack of science is quite rife. Goodness gracious, get alive. Round, 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 the earth is round. Smart people found that the earth is round. There's proof abound, don't fool around. The data's sound, the earth is round. Like an apple or a melon, being sailed by brave Magellan. Yet you ask, is this all true? What the hell, what's wrong with you? Like a snowball or a beat, it spins through space, it's really sweet. Your lack of science is quite rife. Goodness gracious, get alive. Round, 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 the earth is round. Smart people found that the earth is round. There's proof abound, don't fool around. The data's sound, the earth is round. Like an apple or a melon, being sailed by brave Magellan. Yet you ask, is this all true? What the hell, what's wrong with you? Like a snowball or a beat, it spins through space, it's really sweet. Your lack of science is quite rife. Goodness gracious, get alive. Round, 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 the earth is round. Smart people found that the earth is round. There's proof abound, don't fool around. The data's sound, the earth is round. Like an apple or a melon, being sailed by brave Magellan. Yet you ask, is this all true? What the hell, what's wrong with you? Like a snowball or a beat, it spins through space, it's really sweet. Your lack of science is quite rife. Goodness gracious, get alive. Round, 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 the earth is round. Smart people found that the earth is round. There's proof abound, don't fool around. The data's sound, the earth is round. Like an apple or a melon, being sailed by brave Magellan. Yet you ask, is this all true? What the hell, what's wrong with you? Like a snowball or a beat.
Hello, how are we doing? Thank you very much for joining me. Just while I was waiting there, I saw a lot of you asking about that song, the opening song, so I'm going to chat with the guy that made it for me. So a guy made it specially for me. I'm going to chat with him and we're going to have a look to see if we can come up with some way that we can put it together so we can release it to everyone. So watch this space. Right, quick cup of tea. Out of all the videos I've done, I got the most amount of comments, negative comments about how I made my coffee. Everything, seriously, coffee was the worst thing. Right, okay. Thank you very, very much for joining me tonight. Tonight is the first in a series of 4 or 5 lectures about astronomy. It's going to be a beginner's astronomy course. I must stress that it is an introduction to astronomy. It is beginner, so if you know a lot about astronomy already, you might find it quite boring. It is purely designed so people can go out into their own back gardens, hence the name of the slide here, backyard astronomy, into your gardens and go out and do astronomy for yourself. This is the aim of the whole thing. If this is received well, then and people want to see more, then we will do I will do something a little bit more in depth, a little bit more complicated. So we'll see how it goes. Okay, just to kind of clarify tonight, this is a flat earth and conspiracy theory free zone. It's purely educational tonight. Moderators, if any flat earthers come in and they start talking about flat earth or anything like that, then please just kick them straight away. I want this to be purely just educational tonight. Yes, before I begin, a couple of super chats to say thank you for. There were 2 at the beginning which I can't go back to, which I will thank you afterwards, but Curve Gaming, thank you very much. I think that's it for the moment. Okay, cool. I will keep an eye on the chat if as and when I can, and I will take questions at certain points. So there'll be certain points that I'll ask questions. I'll have a quick look. If you can address me with the @SimonDan, and I'll pick a couple and answer them. Oh wow, 1.3k, brilliant. And that's about it. So we'll start any second. Let's have a look who we've got. Oh, cool, quite a few of the usuals, good stuff. Conspiracy cats, hello. Who else have we got? Factard, hi. Can I put chat on slow mode? It is, I think it is on slow mode. I'll double check. in a minute. Okay, so Safety Steve, thank you very much. People who are talking about lighting, I can't really fix the lighting. It's a really bad bulb in the room, but it doesn't really worry too much about me. You just got to listen to me and watch the slides. Okay, here we go. Backyard astronomy. So a little kind of overview on what kind of is this 4 or 5 4 or 5 month lectures are about. So tonight is the first lecture, which is going to be the history of astronomy. So we're going to talk a little bit about how we've got to where we are today. Ben Benson, thank you very much. So it'd be the story about how the scientists in history have developed their techniques and how we've got to where we are today. That's what tonight's about. Next month it will be a little bit more about how we can use our eyes, how we can go out into our back garden without any instrumentation and go out and view the night sky. A little bit as well about some of the key words that we need to know. Andy Sykes, thank you very much. Henrik Bjork, thank you. Amai, aka Kit Kat, you're awesome. Please keep up the awesome work. I will do. Thank you. And just another Bucky lover. Astronomy is never boring. Love your work. Thank you very much. Fight the Flat Earth. How you doing? Brilliant. Okay. So next month, the lecture will be kind of keywords, what we need to know, and how we can use our eyes to go outside and view the night sky. The third month, the third lecture will be all about the solar system. Lecture 4 is more about the deep sky objects, so stuff that is outside of our solar system. And lecture 5 is hopefully, weather permitting, going to be outside with the telescope trying to get a few shots. That's going to be a very kind of keep our fingers crossed job, that one. So we'll see how that goes. If the weather's good, we'll go out. We'll see if we can get some good images. If not, we won't worry. But the first 4 are the key ones to worry about. Jonas, thank you very much. And Grandad Rocket, thank you as well. Okay, so history of astronomy. Now, I mean, a lot of you have seen most of my videos. So when I say something like what is meant by the term geocentric, most of you probably know what that means. It means kind of Earth. Earth is central. Earth is the centre. And this was the understood kind of astronomy of the world 2,000 years ago. This is what was the known. This is what people understood it to be like, and it's how the belief system was. So Earth was at the centre. You had the moon rotating around Earth. You had Mercury, Venus, then the Sun, then Mars, Jupiter, Saturn, and then the stars. And the idea was that they were all in these rotating spheres. I'm not sure if you can see. Forget a pointer. There we go. There we go. Okay. So, so the planets were in order up to Saturn. Uranus and Neptune yet to be discovered. So they were in order. They got that right. But the Sun was kind of tucked in there between Mars and Venus. And they noticed that the planets did these little epicycles. So they did kind of their own little motions in orbit as they went round the Earth. So this was the perceived model for a long, long time. It was the Ptolemaic model. Thank you, Call of the Void, and thank you, Sam P. So this was well understood, and there was no arguments at all on this kind of model when it first came out, or when it was first kind of put out there as the real truth. And then these 5 men came along, and they were around between 1473 and 1727. Now, I'll have a quick look at the chat. Anyone recognise any of those faces? I know we're about 20 seconds behind. So I think the obvious one on the right is Newton. So if you're from, you don't even have to be from the UK. So Newton's on the right. Anyone recognise any of the others? Copernicus, yeah, realistically speaking, Copernicus on the left, on the far left, good. Galileo in the middle, spot on. Any idea on the 1 second to left? Or the 1 second to right? Yeah, we got Newton, got Copernicus. Everyone's going, oh, here we go. Geostrebe, of course. Copernicus, Brahe, Galileo, Kepler, and Newton. So yeah, these were the 5 men that pretty much changed the course of astronomy as we know it. And we'll start with Copernicus. So Copernicus was a Pole, but we need to talk about a couple of things before we move on. And one is religion and science. Now, today they are very separate. There's a real divide between religion and science. But back then, back in the day when Copernicus was around, It was pretty much one and the same. Religion controlled science, controlled literature, controlled pretty much everything. And they kind of had the say on what books were published and things like that. So when we think about religion and science, we have to think about them as one when we're talking about these religious figures. That's one thing we absolutely have to take into account. Second thing is astronomy and astrology. Now again, these two are separate today. One is a proper science, and the other is in a weekly magazine, and it tells you how your life is the same as one of every other 12 people in the world. So these are very different. But again, back then, astronomy and astrology were pretty much the same thing. And we've also got to think about the old method, the Ptolemaic method, and Copernicus, because he was pretty much the first guy to say, no, the Earth is not the centre of the universe, because back then solar system galaxies were not conceived. It was just the universe, it's just what it was. So Ptolemy and Copernicus would definitely had two very, very, very different ideas. Okay, Copernicus lost his father when he was very young. So his mother's brother, his maternal uncle, became kind of the prominent father figure in his life. And it's a guy called George Watson Road, and that's Lucas Watson Road, sorry, and that's him on the left there. And he was a bishop. Thank you, Kirk. Thank you. And after Copernicus received a degree in religious law, Lucas organised for him to join the church in a lifetime position. That's the way it was back then. Copernicus was going to work in the church for his whole life. That was kind of how it was mapped out for him. Fulmer, hey, great, thank you very much. Thank you, Fulmer. Nice that you can make it. And he was a secret astronomer. So the job in the church paid really well, and it afforded him to do what he wanted. And he chose astronomy as his kind of hobby. And he did that for the rest of his life, and he did it in secret behind closed doors. Factard, I need a few more mods. I do. I've got loads, but they're just not here. So really, Copernicus was a church official secretly writing his astronomical masterpiece over a 40-year period in the corner of a tower next to a parish church. This was his life. It was working kind of in a church, and undercover he was studying astronomy and writing a book. Okay, that was weird. So, we'll move on to that word, heliocentrism. So I think we all know what heliocentrism means. It means sun is at centre, or sun is at the centre. So at some point between 1508 and 1514, Copernicus wrote a short paper called Commentariolus, or Little Commentary. And he distributed it amongst his friends that had astronomical interests. And it was here that he postulated that the Earth, this was the first time that he said that the Earth was not the centre of the universe, and it was in fact the Sun. And that was it. This is it here. Little Commentary. So it was the first kind of thing that he put out. And it was pretty much the first mention of the Earth not being the centre of the universe. But not only this, he also noted that the further away a planet is, the longer it takes to orbit the sun. Now that's obvious. You know, you'd think that now. You know, it's not something that's hard to figure out. But back then, it was pretty groundbreaking. Donovan, thank you very much. And this was Copernicus's first real kind of map of the solar system, or the universe as they knew it. So he had the sun in the middle. He had Mercury, Venus. He had Earth, and he had the moon going around the Earth. He had Mars, Jupiter, Saturn. Then he had this kind of ring here called the stellar vacuum. It's a kind of stellar vacuum, interstitium amplificum. And outside of that were the stars. So he had it exactly right. He had the order of the planets right. He had the moon going around Earth. Fur001, thank you very much. He had the moon going around Earth, and he had the stars in kind of like a sphere outside of the planetary region. That's how it was. Henrik, thank you very much. Now, every great astronomer in this golden age of discovery all released a masterpiece of a book, and each one was a little bit more groundbreaking than the last. Now, Copernicus, he did a book called De Revolutionibus Orbium Coelestium, so on the revolutions of the heavenly spheres. But it wasn't published until 1543, and it was hidden for 36 years, and Copernicus himself was only given a printed copy a few hours before he died. Now, the story was, he was on his deathbed, and he had a colleague who was in the publishing game, and this colleague wrote the foreword to the book. Now, he wrote it in such a way that it was allowed to be published by the church. There was a worry that Copernicus obviously wouldn't get his work published because they would see it as, not true. It was going against what they believed to be the truth. So this publisher friend of his wrote the foreword and said it in a way that it was only a theory. It was nothing that he was saying was completely true, and it managed to get the book published. He rushed to Copernicus to give him a copy. Copernicus woke up, saw that he was holding his book, had a massive stroke, and then died. So it's kind of romantic in that way, but it was a shame he didn't get to see the impact that his work had. So he really was a secret astronomer, and he did it all behind closed doors. And that was, or this is, the publication. So you can see he's got his map on the back. Saxy81, thank you very much. And it doesn't look like too much, does it? But it really was groundbreaking. And in it, he professed a lot of things. He said the centre of the Earth is not the centre of the universe. He said that all the spheres revolve around the Sun, therefore the Sun has a central location in the universe. This is in the 1400s, remember. He said the distance from the Earth to the Sun is very small in comparison with the stars. First three things, all correct. He said, whatever motion appears in the sky arises not from its motion, but the Earth's motion. Again, spot on. He also said the Earth performs a complete rotation on its fixed poles in a daily motion, whilst the sky remains unchanged. And he said what appears to us as the motion of the Sun arises from the motion of the Earth. All in the 1400s, all postulated by Copernicus. Justin Noka, thank you. Yeah, I realise I'm slightly over the text in the corner. Sorry about that. Okay. So there were a few kinks in the journey. So as Copernicus expected, what he thought would happen did happen. The theory was denounced eventually as false and altogether opposed to the Holy Scriptures. And they banned it in 1616. So bearing in mind this is a long time later, they've banned this work. So it'd been out for quite some time before they banned it. But it was eventually removed from the list of forbidden reading material. Today, a recent sale of a first edition copy fetched over $2 million. Okay, so we've looked at Copernicus. He's kind of the start of the story. He gets the ball rolling. Does anyone have any questions related to Copernicus? I'll try and answer one or two if you do. If not, we'll carry on. Thin fourth, very funny. There's always someone with the Uranus joke. Tusk Music, go whenever you like, buddy. Okay, so we've got a couple coming through now. Keep the caffeine flowing. How did he observe these things? Stan Kuhn? With his eyes. Telescopes weren't invented then, so it was all with his eyes. Mr. T, how did he have a telescope in 1400? He didn't. Pretty much a lot of those questions are the same. How did he observe it? What country was in from Ricardo? Poland. You're right. He didn't have a telescope. Graham Houston, are you setting homework, Simon Dan? Actually, the second lecture there is homework, so watch out for that. Okay, let's continue. Tycho Brahe and Johannes Kepler, we kind of need to talk about these two together. Their stories are intertwined. And there they are. Brahe and Kepler. Kepler, in my opinion, one of the most underrated scientists of history, and that was proven by my poll yesterday when I asked about one of the most influential astronomers or scientists of the past, and Kepler only got 3%. So my point is proven that he is underrated. Robin Sturgeon, thank you very much. Okay, let's start with Brahe. Brahe was born in 1546, which was 3 years after Copernicus died. At 17, he was becoming frustrated with the predicted conjunction of Jupiter and Saturn and decided to secretly record the positions of the planets in the sky himself. Now, a conjunction is where one planet appears to pass behind or in front of another planet. So they're quite rare. If you can catch one, it's great viewing. So Brahe was becoming frustrated that these predictions of these planets, Jupiter and Saturn, of coming together weren't correct. So he decided to make his own observations so that they would be correct. In 1572, his uncle and Brahe set up a lab in an old abbey for the scientific study of astronomy and alchemy. And it was here that he earned a name for himself as having the most precisely accurate observations in all of recorded history. He was he was infamous. Every single observation had to be exactly right. They were the most precise, as I said, the most precise in history. And he became famous for it. And when the Danes showed interest in moving to Basel, which had much better facilities, King Frederick of Denmark made him an offer that he couldn't refuse. And it was this. He gave Tycho permission to build an observatory on an island called Hven. And he did that. And for the next 20 years, Brahe and his assistants amassed a treasure trove of data on the stars and the motions of planets. And he oversaw each and every observation with tenacity and fury. And this is an artist's impression of Uraniborg, of his observatory. So you can see the viewing platforms here. No telescope still. It's still all done with his eyes. And these observations were extremely accurate, as I said. Tracking the motions of the planets against the stars, tracking the stars themselves, meticulously recording all their positions night after night after night for 20 years. It was a wonderful set of data. Unfortunately, though, for Brahe, King Frederick died, and his son Christian IV took the throne. Now, in 1597, when Tycho fell out with the new king, he was eventually banished from his homeland, from Denmark. But Brahe was determined, and it forced him to move all his instruments to Germany, where he had to find a new sponsor and a new observatory. Okay, this needs to be continued, this story, so we'll put this one on hold of Brahe, and we'll move on to Kepler. Whisper Mason, thank you very much. So Johannes Kepler was born in 1571, and he was a very sick and frail child, and he suffered from a lot of physical ailments throughout his youth. However, his philosophical and intellectual side was as brilliant as his physique was poor. He was exceptional, basically, from a very young age, and he went on to study at the prestigious Tübingen University, but as a student of theology. So again, we're looking at the tie between religion and science. Now this guy's a guy called Michael Meislin, and he was one of Kepler's teachers, and he was a very, very capable astronomer. And he noticed that Kepler had a real interest in astronomy. Now Kepler was a mathematician by trade, but he had an interest in astronomy, a strong one. But crucially, he introduced Kepler to the ideas of Copernicus, and that led him down a new path of thinking. In 1594, after the death of a religious mathematics teacher in Graz, Tübingen University sent Kepler to replace him, and he was only 22 years of age. A mathematics teacher at a university, 22 years of age. He was in an astronomy lesson one day, teaching his students, and he had a stark realization about the makeup of the universe. And after some heavy calculations, he proceeded to come up with a model of the universe based on geometric shapes. And there it is. This was his model. And it was wrong. Clearly it was wrong, but it was a really good guess. Rano Gaming, thank you very much. And he explained this model in his first scientific publication, which was Mysterium Cosmographicum, or The Secret of the Universe. And that was in 1596. He was convinced he'd found God's blueprint. He was strictly religious, Kepler. And everything, maths, astronomy, everything, was God's work. That's what he believed. So, 3rd of February 1600. Kepler sent out many copies of this Mysterium Cosmographicum, and one of them ended up in the hands of Tycho Brahe. And Brahe knew immediately that he should have Kepler work with him at his new observatory in Prague. Chris Kelling, thank you very much. Kepler was now unemployed. There was various religious changes where he worked, so the opportunity to work with Brahe was a welcome one, and they finally got together on the 3rd of Feb 1600. Two giants in the world of maths and astronomy, and they got together on the 3rd of Feb 1600. Lenny Gemtrod, thank you very much. With Kepler on board and his long-term assistant Longo Monotonus by his side, Brahe was desperate to start a new golden age of astronomy. And he started with Mars. And there was a problem with Mars. And Brahe gave to Kepler a job. He said, this is your first task. He said, take my incredibly accurate observations of Mars and figure out why there's always an error with the prediction of Mars's position in the sky. Now, there's a couple of things we need to think of first before we talk about this. Mike Robbins, thank you very much. Brahe and Kepler had different ideas. Now, Kepler had the Copernican model on his mind. He believed that the sun was at the centre and that everything orbited the sun. Brahe had kind of a weird sort of hybrid model going on. Now, he believed that the planets did go around the sun, but he also believed that the sun went round the earth. So he had like this hybrid model, and it was a bit of a problem for the two of them, because Kepler was quite stubborn on it, as was Brahe. They believed in different models, but the key thing was that they both understood that objects orbited the sun. Second thing is, there's not really any perfect circles in astronomy. So when we're talking about orbits, there isn't really any perfectly circular orbits. They are ellipses, so they're non-perfect circles. They have an eccentricity. And again, this is something that Kepler figured out. It was actually one of the best moves in history to assign Kepler this job because he cracked it in 5 years. Now, he made a bet with Longomontanus that he'd do it in 2 weeks. So he lost the bet, but he did do it. And the whole project led to a new set of physical laws that stand to this day. And this was the problem here. So the dotted line here was the predicted position of Mars in the sky. Which of course does not match reality, and Kepler managed to get it to this line here with his mathematics and with, of course, Brahe's observations. Wow, 1,700, brilliant. Okay, in 1601 Brahe collapsed from a severe bladder ailment, and 5 days later he found himself on his deathbed. With Longomontanus and close family away from Prague and only Kepler around, Brahe had no option but to leave all his astronomical measurements to Kepler. No other option. He begged Kepler to use the hybrid system that he believed when figuring out planetary orbits, but Kepler knew it was wrong. Kepler knew it wasn't right. He knew that the Copernicus method, or the Copernican way of thinking, was the way to go, and he had no intention of using that model. And he came up with 3 laws. Law 1 is that planets travel in elliptical orbit. So there's 2 focal points, and planets orbit those focal points. They're not perfectly circular. There's an eccentricity, as I stated. Law 2. A line segment joining the planet and the sun sweeps out equal areas during equal intervals of time. Anyone who saw a recent video I did on Kepler's second law will understand that basically the closer you are to the sun, the faster you are moving in your orbit. And the third law was the square of the orbital period of a planet is proportional to the cube of its distance from the sun. So basically, if you take the orbital period of a planet and square it, it's proportional to the distance from the sun cubed, and if you put it on a logarithmic graph like this, you'll see there's a clear relationship there. And he did all this with just the observations and pure mathematics. Very clever guy. Arguably, one of the most important books to have ever been written was Astronomy Nova, and it was Kepler's work. It uses real physical science to explain the motion of the planets in the solar system. The Lubis, thank you very much, and Roy Fraser, thank you very much. Fight the Flat Earth, I can't mod anyone because I'm using full screen. I can't come off it. It's 650 pages long, and it takes readers through every step he made during the total 9-year investigation that he made into the orbit of Mars. Okay, anyone got any questions on Brahe or Kepler? Hi Marvel Gal, nice to see you. MST Sounds, was Brahe a reincarnation of Copernicus? I don't think so, no. Rasmus Harbo, thank you very much. Oh, Mandelbrot Set, how you doing? Glad you can join us. Rapid X, how you doing? Risus, did they use telescopes? No, still not really at the telescope stage yet. Launchpad Astronomy, I understand Brahe was reluctant to give Kepler all of his data. Absolutely. He would rather have left it to his aides and his family, but they weren't around, like I said. And he knew that Kepler was a proponent of Copernicus's model and Brahe wasn't. Tommy, that's a great question. He did credit Brahe's work. We'll find out in a minute a little bit more about Kepler's personality. He was a very decent, genuine guy, actually. Kirk Snustad, thank you very much. Yep, Rysas, all observations were done by Brahe. Henrik, thank you very much. Why did Brahe have this hybrid model? So Brahe, because of his observations, he was able to see that things were orbiting the sun, but for some reason he was still set in the old way of the Earth being the centre, the geocentric model. So he made his own model off the back of his own observations, but he couldn't quite push himself to that heliocentric model. RapidX, hello. Where are we? Justin Kelly, Hank, thank you. Deathpool, Marvel Girl's missing her spanner. I know I can't do any spanners at the moment because I'm live on full screen, but once I'm done, I'll make sure everyone who needs spanners has got them for next time. Okay, let's move on. So the next one in the story is Galileo. Galilei. Anytime, here we go. He was born in 1564 in Pisa, and he was the eldest of 6 children. As a young man, Galileo was expected to become a priest, so we're still in this very, very strong religious era. He was expected to become a priest after his father enrolled him into a monastery. However, this didn't suit him, so he left to take a medical degree, but he switched to mathematics halfway through, and an interest in the physical sciences followed afterwards. At 26, he was appointed Professor of Mathematics at Pisa. Now, because he was a bit younger, he was a bit cockier, and also he was a bit of a knob, and that provoked a lot of the older academics in the university, and therefore his contract wasn't renewed. So he basically got sacked for being an arse. But he'd established a reputation in maths and mechanics, and he secured a position at the University of Padua. During this 18-year tenure, he fathered 3 children out of wedlock, despite professing to be a devout Roman Catholic. Now, Galileo was brought up with the traditional Ptolemy view. Now, we're talking here, Europe is easy to get around now. Back then, you might as well have been on the other side of the world. We've talked about Copernicus, Poland, we've talked about Brahe, Denmark, and now Galileo in Italy. So it took a long time for information to spread. So Galileo was still brought up on this Ptolemy model that Earth was at the centre and that all the planets orbited Earth. Steen Bronk, thank you very much. But by the time he arrived at Padua University, the work of Tycho, the work of Kepler and Copernicus was starting to undermine this belief. It was starting to push through. But before he delved into astronomy, he focused on classical physics, force, general motion, stuff like that. And his work actually inspired Einstein when he worked on special relativity. Now, Galileo didn't invent the telescope. He didn't come up with the idea of it. However, the ones he built were vastly superior to the originals. I believe the originals came from China. Now in 1609 he turned one of his telescopes to the moon, and he noticed that it wasn't smooth and uniform like it looks with the naked eye, but it was full of cavities. Now it takes no genius to guess that those cavities are of course craters, and in 1610 he made what he considered his most important discovery when he turned his telescope to Jupiter. And there he is, turning his telescope to Jupiter. And this was his actual recordings. Now, the big blob in the middle is Jupiter. And the little starry things there, any idea? I know we're 20 seconds behind, but I'll wait. Any idea what these little starry things are? So he's taking measurements every night. So 2nd, 3rd, 4th, 6th, 8th, 10th, 11th, 12th. What are these starry things? Any idea? Ludicrous speed, Lewis Hackett, yes, the moons. Spot on. So every single night, Galileo, well not every night, but most nights, Galileo was looking up and he was tracking the positions of moons around Jupiter. Now, if you're brought up to believe in a geocentric universe where everything orbits Earth and you're pointing your telescope to Jupiter and noticing there are objects orbiting Jupiter, that's going to put a massive dent in your belief system. He had observational evidence to prove that not everything orbited Earth. So, we got a little bit of a face-off here between Galileo and Kepler. They lived in the same era, there's no doubt about that. But it's fairly certain that they didn't meet. Kepler was German, Galileo Italian. It was a long distance back then. But they did write to each other on a number of occasions. However, after a number of positive exchanges, Galileo suddenly began to ignore Kepler's letters. It would be fair to say that the Italian was intimidated by Kepler's brilliance. Despite this, Kepler still wrote to Galileo and he was in continual support of his work and telescopic activities, and in return, Galileo rarely mentioned Kepler's name, refuting and ignoring all of his main ideas. The three Kepler's laws, Galileo said they were rubbish. Didn't believe him at all. Call of the Void, thank you very much. Mandelbrot set, you can see those moons with mere binoculars, absolutely. Kepler was a kind, sensitive man who never felt the need for competition or self-promotion, and Galileo was opposite in all of those respects. He was not a nice man. As I said, bit of a knob. Kepler was great though, really nice. Okay, in 1616, Galileo got into trouble with the church because he eventually jumped on board with the Copernican model, but because of his attitude, because of his mindset, he went straight in and he taught it as the sole truth. And he released a book, Dialogue Concerning the Two Chief World Systems. And upon its release, he was ordered to appear before the infamous Holy Office in Rome at the age of 68. Now, if you're going to publish a book that's going to go against all of historical beliefs, living in Rome is probably not the best place you could be. Following a papal trial in which he was found vehemently suspect of heresy, Galileo was placed under house arrest and his movements was restricted by the Pope. And there he is, under trial. In 1638, Galileo went blind and he died on the 8th of January 1642. Oh, that's almost the anniversary of his death. After a fever and heart palpitations. His work was banned by the Inquisition until 1718, and eventually the Church admitted that the heliocentric model was correct in 1835. Now this next bit is hilarious. In 1992, just say that again, 1992, Pope John Paul II expressed regret at how the whole Galileo affair was handled. He went on to officially concede that the results of a study conducted by the Pontifical Council showed that the Earth is indeed not stationary. And that always makes me laugh. $1800, brilliant. Okay, any questions on Galileo? Boaty McBoatface, how you doing? Yes, George Short, 1992. They finally admitted it. Datsko, yes I am. Morton, you can recommend Bill Bryson's book, A Short History and Everything. Agree there, it is a great account. George Short, who figured out there were other galaxies other than the Milky Way? That's for a different lesson, but Edwin Hubble was the main proprietor of that. Did his outlandish behaviour put supporters off? Good question. I'll imagine so. He wasn't a nice man. Probably didn't really have many supporters. He was clever, don't get me wrong. He was a genius, but he was a bit of a knob. Potato MC. How much NASA paying you? 2 packets of crisps and a Mars bar. Okay, let's move on. So the last one is Sir Isaac Newton. Oh, Bjorn Kamitz, thank you very, very much. Thank you. Okay, Sir Isaac Newton. He is obviously British, and he was born on Christmas Day in 1642, and that was actually the year that Galileo died, funnily enough, in the village of Woolsthorpe in Lincolnshire. He was born tiny and weak, and he wasn't expected to survive his first day, but thankfully for humanity, he did. I'm not exaggerating that. Thankfully for humanity, he did. As a boy, he enjoyed making mechanical devices such as clocks and windmills, and showed a liking for mathematics. And in 1661, he attended Trinity College, Cambridge, with the financial help of his uncle. Now, Cambridge University, believe it or not, was still flogging the Ptolemaic horse, despite the works of Copernicus, Kepler and Galileo all being readily available. Well, that's not like the UK to be behind on something like that, is it? During his time there, Newton amassed a huge amount of writings with the new philosophy and physics of his time. So he was becoming increasingly aware of Copernicus, Kepler and Galileo's work. He was studying that work in his spare time, and he was definitely interested in it. Mattia, thank you very much. And in 1665, he received his degree with very little recognition. Shortly after this, the Great Plague swept through London, so Newton went back to his home village to expand on his independent studies. Now, things I did before I was 26. So I'm 36 now. So things I did before I was 26. I travelled to Australia. I confirm it exists. I travelled to Australia and I won a 6-a-side competition. That pretty much sums up my achievements. Before I was 26. Now, things Newton did before he was 26. I just want you to all picture yourselves at 26 and looking back in time, or if you're under 26, look back and think, what have I achieved so far? This is what Newton achieved before he was 26. Discovered binomial theorem, invented calculus practically on a dare, discovered the laws of motion, discovered the laws of optics, made advancements in understanding planetary motion, and invented a new type of telescope. So that's quite a lot. The calculus thing, anyone who's studied further than A-level maths or A-level maths and onwards can thank Newton, possibly Leibniz too, for calculus. I don't know about you, but that was a bit of a pain in the bum, that one. But yes, Newton was a phenomenal mind. Okay. There it is. There is the famous picture. I'm sure everyone can appreciate what this is. Yes? Turquoise Laura? No wife and kids before 26. So this was the famous moment. Kanuk M, thank you very much. Now, unfortunately, this didn't happen. There was never a point where Newton was sat under a tree and there was never a point when he saw an apple fall, and there was never a point where he thought, that's gravity. This scenario did not happen. Henrik Bjork, who might have invented calculus if he did not, possibly. So, a little bit more on that in a minute, but just so we understand, the apple falling from the tree did not happen. A fellow scientist of Isaac Newton's, Robert Hooke, wrote to Newton one day and asked him if he had thought about why objects would be bent into a curved path as they passed the sun. Without admitting it, this is the first time that the concept of universal gravity entered Newton's mind. He fabricated the apple falling from the tree story as a way to discredit Hooke's input in an interview in his 60s. So basically, when he was older and he was being interviewed, and he didn't want Hooke to take any credit for the discovery of gravity, and he made up the story of the falling apple to discredit any input of Hooke. He didn't arrive to the correct notion of universal gravitation until 1679, which is over 10 years later than he originally states. The idea was there, but he didn't arrive at the correct notion until 10 years later than he stated. Grimlock, thank you very much. Okay. Hopefully you recognise the name Halley, Edmund Halley. In 1684, a young Edmund Halley paid a visit to Newton. He asked Newton a question about planetary orbits, and it prompted him to think more about celestial mechanics and the universe. Newton said, "I'll work on it. Go away, give me a couple of weeks, I'll work on it." 3 months later, Newton sent Halley a short tract entitled On Motion, with the promise of more to follow. In 2 years, On Motion grew into Philosophiae Naturalis Principia Mathematica. It was Newton's masterpiece, and one of the fundamental works in the entirety of modern science. In it, he proved the idea of universal gravitation mathematically, which culminated with the summary of his 3 laws of motion. And there it is. It looks pretty hefty, doesn't it? Halley was studying a comet that had passed in 1682, and he applied Newton's new theory to this comet's orbit. Using Newton's results, Halley discovered that this comet had the same orbit as that of one in 1607. He then examined reports of a comet in 1531, and again it had the same orbit. Halley predicted that this was the same comet returning to Earth every 76 years, and said that the comet would return again in 1758. He died in 1742, unfortunately, but the world's astronomers did not forget the prediction, and after months of disappointment, it finally made an appearance on Christmas night, which quite beautifully was Newton's birthday. And there it is. So after Principia, Newton had a nervous breakdown, and unfortunately he never recovered. From then until his death 35 years later, he made no major scientific discoveries and instead dabbled in alchemy and theology. In 1697 he was appointed Master of the Royal Mint, and in 1705 he was knighted. In 1727 Newton died, and he was buried at Westminster Abbey. So there we have it. Copernicus, Brahe, Galileo, Kepler and Newton. The death of Newton bringing an end to a glorious period of discovery in physical science that lasted less than 200 years, and yet formulated most of the methods and models on which most of subsequent science is based. And that is a brief history of astronomy and why we, or how we are where we are today. Thank you all very much. Anyone got any questions now that we're done? Geraldus, thank you very much. Nicholas, thank you very much. Tommy, off topic, what happened to your finger? Yeah, okay, I'm going to address this because I get so many comments asking me what happened to my finger. I was running the other night, it was about 4 weeks ago now. I bashed my finger. This bit of the finger was bent like that. So I had to go to have an x-ray. I'd snapped the tendon on the top, and I've got to wear this for 8 weeks. What am I going to do? Justin Kelly, thanks, great work, lecture, thank you very much. Victory shout, NZ, thank you. Thank you, the gamer NL, thank you very much. Call of the Void, thank you. Creaky Blinder, how you doing? Thank you very much. Aid Wolf, nice working in Den. Have a beer on me, sir. Thank you very much. Yes, Gary, Hook was born very close to you. Andy Will, no problem. Henrik Bjork, again, thank you very much. Emil, Formsmark, thank you. Brilliant. Okay, guys, thank you very, very much for coming. As I said, this was lecture 1, the history of astronomy. Always nice to have a look at where we've come from before we start moving on. Next month, so this will be early February, I'll do lecture 2, which will be all about kind of the keywords we need to understand and a little bit more about naked eye viewing. Almost said naked eye viewing, and a little bit more about a few of the stars and constellations that we can see. So, thank you very much for coming. Thank you very much for watching. Mods, thank you very much. Next time I'll get a few more mods going. Billy Reynolds, Dan, do you have a telescope and video equipment so you could do a live recorded demo of planetary bodies? That is my plan, Billy, for week 5, weather permitting. Month 5, sorry, weather permitting. Okay, that's it. Thank you very much, everyone. I'll see you all on Tuesday, where I'll be doing a collaboration with Godless Engineer, fun enough, on the planet Mars. So I'll see you all then. Thanks very much. Have a good evening.